So we're looking at the backside of our concept byte notes. We have 9 problems. We are working the one right in the middle, the 5th one. In this problem, we have 3 things inside the parentheses. We have a 5, we have a g to the 4th, and we have an h to the negative 3rd. So I'm going to go through here, and we can do this in multiple ways. There's multiple ways of going about this problem, okay? I'm just going to show you the way I see it first. Okay, like I told you with all those rules yesterday, we had 7 rules. There is no rule telling you which one of those to do first. So you can work it any way you want as long as you're following the rules. Okay? So the way that I would probably go about this problem is I would probably use this rule that said a times b to the n power is a to the n times b to the n. I would probably use that rule first. So that means in this problem, we have 5 to the negative 3rd power times g to the 4th power to the negative 3rd power times h to the negative 3rd power to the negative 3rd power. Okay? So, next, my next step, I would probably go through and do 2 rules in one step. I would use the rule that a to the negative n power is 1 over a to the n power. And I would use the rule that says a to the m power raised to the n power is a to the mn power. Okay? So, here's what I'm doing, and there's a reason why I'm doing it this way. When I use this rule, my signs are going to change. Right? When I multiply negative 3 and negative 3, I'm going to get a positive 9. So it's going to want to stay where it is, right? Whereas when I multiply these, I'm going to get a negative 12. So it's going to want to move. And this guy is already just a negative exponent. It wants to move. So I wouldn't have to do this all in one step, okay, if you don't want to. It really doesn't make a difference one way or the other. But I'm going to. I'm going to say, hey, this guy wants to move down. So it's going to move into the denominator. I'm not going to move any of the other 2. I'm going to leave those where they're at. But I'm going to use this rule in order to multiply the exponents. Okay? So what that gives me then is g to the negative 12th power, h to the 9th power, over 5 to the positive 3rd power. Well, we're not quite done yet. I have to use this rule a second time because now g to the negative 12th power wants to move. And so I have h to the 9th power over, quick question, what is 5 to the 3rd power? 125. So this is going to be 125 g to the 12th power. All right, so the next problem that we want to do starts with 16. So you're talking about the 7th problem there, 16q to the 0 power, right? Okay. So 16q to the 0 power, r to the negative 6th power, over 4q to the negative 3rd power, r to the negative 7th power. The very first thing I would do anytime I see an exponent of 0, I would use our rule a to the 0 power equals 1. So that means q to the 0 power equals 1. What's 1 times 16? 16. So we now have 16 r to the negative 6th power on the top. Okay? Please don't think, oh, so it cancels out. It didn't cancel out. Okay? I crossed it out, yes, but it didn't cancel out. Okay? It doesn't cancel out. Q to the 0 power is 1. And so I took 1 times 16 and got 16. Okay? It's not canceling out. It's becoming a 1. Okay? So, the next thing that I would do is I would say, well, I got a 16 on top and a 4 on the bottom. They're happy where they're at, but I can reduce them. 4 goes into 16 4 times. Yep, yeah, there's still a 1 on the bottom, yep. All right, so I'm going to rewrite because I don't like it when I have too much work going on. It looks all messy, so I'm going to rewrite what I have now. I have 4r to the negative 6th power over q to the negative 3rd power r to the negative 7th power. Okay? Well, next, I should use the rule that says a to the negative n power equals 1 over a to the positive n power. That means negative exponents want to move, right? Negative exponents want to move to become positive. So I have an angry exponent here, wants to move down. I have an angry exponent here, wants to move up. An angry exponent here wants to move up. So again, rewriting what I have 4r to the 7th power, q to the 3rd power, which I should flip those around, shouldn't I? I started writing those in the wrong order. So, let's did it again. I'm having issues here. All right. Deep breaths, Bobier, deep breaths. All right. Q to the 3rd power, r to the 7th power, over r to the 6th power. All right. Last thing. Can we do anything with that fraction?
The r can be reduced.
R can be reduced. R can be reduced. So I have 6 r's multiplied together on the bottom. I have 7 r's multiplied together on the top. 6 from the bottom cancel with 6 of them from the top, leaving me with what? An r to the 1st power on the top. Yeah. And what's on the bottom? What's left on the bottom? Just a 1. But am I going to write my answer over 1? No. No. So my answer is going to be 4 q to the 3rd power r. So today we're going to start talking about our 6-1 notes. And the first thing we need to talk about in our 6-1 notes is just radicals in general. Okay? Radicals, that is the proper name for what you guys call square roots. Okay? We can't call them all square roots because square roots indicates a specific type of radical or a specific type of root. Okay? We are dealing with this situation now. Here's kind of the anatomy of a radical. Okay? The actual radical symbol itself, it's the radical sign. You guys called it the square root. Stop calling it the square root unless we are actually talking about square roots. Because we are now going to start using different indexes. A square root, for example, the square root of 4, we write it this way, but there is assumed a 2 to be the index. We don't write it there, just like we don't write the 1 out in front of 1x, or we don't write the 1 for the exponent of x to the 1st power. Okay? We don't write those things because we know they're there. Same thing with square roots. We don't write the 2 because we know if it's not shown, the index is 2. Okay? But now, we're going to start working with cubic roots of, say, 27, or the 5th root of, say, 125. Okay? So, we're going to start dealing with other indexes, other roots. So, the item that is sitting up here, that little number, is called the index. The symbol itself is the radical sign. And the number inside the radical sign is called the radicand. Okay, that is called the radicand. So, a couple of things you need to know about roots, different numbered roots. If the index is odd, so if we're talking about the cubic root, which is the index of 3, or 5th root, or 7th root, or any odd numbered index, then we get one answer. We can get one answer, and that answer can be both positive, can be a positive answer or a negative answer. Okay? For example, if I have, let's go ahead and look at the cubic root of negative 8. Cubic root of negative 8. What they're asking us here is what number multiplied by itself 3 times gives us negative 8?
Negative 2.
Negative 2. They're saying negative 2 times negative 2 times negative 2 is negative 8. And that's true, right? Yeah, absolutely. So therefore, the cubic root of negative 8 is negative 2. If you have an odd index, you can get a negative answer. You can take the cubic root or the fifth root of a negative number. That is okay to do. Okay? Remember though, unlike having an even index, like a square root, we can't take the square root of negative numbers and get real answers. Right? That gives us imaginary answers. That same thing holds true for fourth roots or sixth roots or eighth roots, any even root. You cannot take the even root of a negative number and still get a real answer. They would give you imaginary answers. Okay? Also, when we are solving equations, for example, if I have x squared equals 9. X squared equals 9. We've solved this a long time ago. You guys all know that we have to take the square root of both sides, and therefore x equals the square root of 9. But how many answers do we get? 2. Positive and negative square root of 9 is 3. When you have an even index, you can get 2 answers when solving equations. Okay? But when you have an odd index, you only can get 1. If I said x cubed equals negative 8, and I went and took the cubic root of both sides, my answer is still going to be just negative 2, not plus and minus. There is only one answer for the cubic root of negative 2. I'm sorry, of negative 8. Okay? All right. The other thing when dealing with even indexes, and we talked about this a long time ago, if you are solving equations and you put in the square root, or if you put in the fourth root, or whatever even root, then you get the 2 answers. If it's already there, we only deal with the principal root, which is the positive. If I just say, what is the square root of 9, your answer is 3. Right? Okay, the only time that 2 answers comes into play is if you're solving equations. On your separate sheet of paper, I would like you guys to go through and make a chart. We're going to call this our roots chart. So at the top of the page, label it roots chart. Okay? It's going to basically look like a multiplication chart. Okay? So across the top of your roots chart, you're going to put x squared, x cubed, x to the fourth, and x to the fifth. Space it out a little bit, make it go across your whole page. Okay, so those are going to be our columns. And then going down, for the x, we're just going to go 1, 2, 3, and I want you to list it all the way down to 10. Number it all the way down to 10. And so all we're doing then is we're filling in this chart. For example, 1 squared is 1. 1 cubed is 1. 1 to the fourth is 1. 1 to the fifth is 1. But how about 2 squared? Oops, definitely not 2. 2 squared is 4. What's 2 to the third power? 8. What's 2 to the fourth power? 16. What's 2 to the fifth power? 32. So on and so forth. 3 squared is 9. 3 cubed is 27. I want you to fill in this chart. So looking at your chart, we should have this. Okay, so going down your chart real quick, I'm just going to list them all. Your x squared. So now that we have our chart made, let's go ahead and take a look at a couple of notes. So back to your 6-1 notes here, if we look at just example A. Looking at example A here, we want to find the real roots. Okay? We want to find the real root. So what is the cubic root of negative 8? First question you should make is, can we take the cubic root of a negative number? Cubic root, yes you can. Odd indexes, you can do that with negative numbers. So we're asking ourselves, what number raised to the third power gives us negative 8? The answer is negative 2. If you use your chart, you should be looking for the x cubes. Okay? Go down to 8, go across and see that it's a 2. But then in your head you should say, okay, well if it's negative inside, it's got to be negative outside. Right? The cubic root of negative 8 is negative 2. Let's look at here. The square root, how do I know it's a square root and not a cubic root? There's no index written. So it's assumed, or it's known, to be a 2. So square root of 0.04 without a calculator. What's the square root of 4? 2. Now remember, square root means that I'm taking a number times itself and I'm getting 0.04. Right? So, if I have two numbers multiplied together, that gives me a number with two numbers behind the decimal point. Each of these numbers must have one number behind the decimal point. Remember how we multiply decimals? Right? So therefore, this must be 0.2. 0.2 times 0.2 gives me 0.04. Okay, let's, how about part C here? Can we take the fourth root of negative 1?
No.
Why not?
That's even.
Even index, right? Even index gives us imaginary solutions, so we're going to say no real solution. No real solution, no real root. There's no real number that can satisfy that. And the last one I want to talk about here quickly is part D. We have the square root of negative 2 squared. It is very tempting to say that the square root cancels the square. Okay, it's tempting to do that, but we can't. I mean, a lot of times it'll work, except when we have negative numbers in here. Okay? Anytime you have a negative number in here and you're dealing with an exponent, you have to do the exponent first. We have to evaluate negative 2 squared. What is that? 4. Negative 2 squared is a positive 4. And now we can say, okay, what is the square root of 4? 2. Okay, once it's positive in there, then if you wanted to think of it as 2 squared and cancel the exponents, that's fine. But when you have a negative in there raised to a power, you have to evaluate that first.